I've already created the base flange to begin with, but so the next thing we want to introduce is the edge flange. So the edge flange tool in the command manager under sheet metal is found here. I'm just going to select this edge to begin with and the opposing side as well. Now the first group box we need to adjust is actually default radius. We want to change that from 1.5 to 10, so giving us a bigger radius. Now if we just go normal 2, like so, we actually want this outside edge to be in line with this edge here. So we're going to choose our flange position to be inside, like so. We'll have it at 90 degrees, but our blind end condition is going to be 200 millimeters, and OK that. So the next thing we're going to do is close off this end here. Now we're going to do another edge flange. We're going to select this inside radius edge here and across. Now what I want is I want this to be 5 millimeters from the right plane. So what I can do is I can actually go in and edit the flange profile. So I'm going to select my dimensioning tool and select this edge, go into my feature tree and select the right plane and dimension off that. I want it 5 millimeters on the opposing side of the right plane, so I'll just reverse the dimension like so and OK that. And we can go back and into our property manager of the edge flange like so. Now we want our default radius to be 1.5 and our gap, that's fine, and our angle at 90 degrees is good. The only thing is we just want to change our flange position. We don't want it cutting into the side here creating a relief. We actually want it outside like so. Okay, so with that all done we can actually OK that. And we've created our first edge flange. Actually, looking at this, I do want the internal radius to be 10, so I'm going to default it and tell it to be 10, like so. That's better. Okay, so the next part I want to do is I want to close this corner off at the bottom. So what we can do is we can go into the command manager at the top, corners, and we can close corner this option. So I select this face here and it'll automatically select the opposing face and create a closed corner like so. We want our end condition to be a butt, so we're going to select that with a 0.1 gap. And turn auto propagation off. And what we're doing with our coplanar faces and narrow corner selected, we're actually going to close this corner off as well. So we'll OK that. And then we have it, we've got a nice closed corner. So the next feature I want to introduce is a jog. Now a jog is found here in the command manager, and what it's asking us to do is select a face and start a sketch for the jog to be about. So I'm going to select this face and I'm going to go normal 2 and create a sketch which is going to be down here like so. Now again we want that dimension from the right plane, so go into the feature tree, select right plane, and I want that dimensioned 3 millimeters, like so. So with that sketch now fully defined, we can actually go back into our sheet metal and jog. Now the first group box it's asking us to select is the fixed face. Now we want our jog to come out towards the screen here and out that way. So I'm going to select this face to be our fixed face. And you can see the preview of the jog so far. So I want the default radius to actually be 0. So it's going to be very, very sharp. So that's not exactly possible with the angle at 90 degrees or 70 degrees as it is. So we're going to change that to 30 degrees, like that. Now we want our blind end condition to be at 1.6, which is correct. Now I just want to talk about this fixed projected length. That's actually projecting right to the end of our flange, edge flange that we created earlier. If I deselect, it'll be more realistic that where that bend comes in, it's actually going to be a little bit shorter. So I want that checked. And I'm going to go ahead and OK those selections. Maybe you want to talk about the jog position. It's actually bending around that sketch line that we created, which is what we want. So we're happy with that now. So we'll OK that, and we have created our jog. So the next thing I want to introduce, well not introduce, but to carry on, is just to finish off this side with an edge flange, sketching out to there. Now we're going to edit this flange profile so that this end sketch line will be actually collinear with this end here, like so. So we'll OK that, and we'll go back into the property manager of that edge flange, and we're going to deselect the default radius, and we're going to change it to be 10 as well. And we want this to be bent outside, which is good, and at 90 degrees, so we're happy with that. And you can see here it matches up quite nicely, giving us options to put a weld down the inside there. Okay, so finally we just want to close this corner off like we did with the other side. So I'm going to go back into the corners and a closed corner. Now the face to extend is going to be this face. It's going to automatically select this face over here, which is not what we want. So we'll just deselect that, and we'll have to go back and reselect our face we want to extend, and the face to match is going to be this one here. Now we want our butt type to be, it is our corner type to be a butt, and we want a gap again 0.1 millimeters. So OK that, and that'll close up nicely like that. Okay, so the next thing we want to introduce is a hem. So a hem is found up in the command manager here, and that is going to create a hem right around the edges like so. Now you can't apply a hem on a bent edge like this, unfortunately, so we'll just carry on. We'll fill out the parameters of what we want. We want a 5 mil distance like so, with a miter gap of 0.1 as tight as possible, although there is no miters where these join because of the round bend here. So with that done, we can OK that. And now we actually have an internal box that's actually quite smooth. So if you can imagine you want to reach in and grab some ammo, you want that to be a smooth edge. And if ammo is being drawn out, you want that to be a smooth edge so it doesn't catch. Okay, so finally just want to mirror this side of the box to the other side. So we'll just go into our mirror tool, features, mirror, and we want to mirror about a face. So we'll select this face, and we want to have this body here. Okay, we'll have merge result checked, which is good, so we'll accept those parameters like so. So because we want to create a hinge at the back, depending on the size of the box, we want that hinge to adjust accordingly. So what I'm going to introduce is a reference dimension. So I select my reference dimension, and I'm going to select our distance that the hinge is going to sit, and I'm going to place that, and I'm going to use that in some global variables that we'll create now. So if I right click on the equations folder and manage equations, I can actually introduce what we want to do first is an instance number. So this instance is going to be used in our linear pattern of the hinge, which will come more apparent as we go along. So I'm going to select that reference dimension, and I'm going to divide it by the approximate width of our hinge, which is 15 millimeters. Tab across, and that's actually giving us a uneven instance number. So what we need is to have that as a round number. So I'm going to go back into this equation, and I'm going to use a global function, and we'll go down to int. Now it's just a matter of deselecting that and going to the rear of the equation, tabbing across, and now it's actually automatically rounded that number down to a round number. I'm going to add another global variable, and this one's going to be instance odd. Now it's because we are creating our hinge at the middle of our box, we need it to be an uneven number. So to do that, we can select our function again, int, and we're going to select our instance that we just created, so this one here, and we're going to divide that by 2, and outside that brackets we're going to times by 2 again, open a new brackets, and plus 1. I'm just going to go to the end there, close that bracket off, and tab across. Then we can see that our instance odd, no matter what, our instance odd is always going to be an odd number. Finally, we want our hinge size. So our hinge size is going to be our distance that it's going to be between, which is our reference dimension down here, and we're going to divide that by our instance odd, which is what we just created. That's going to give us our approximate or our exact size of our hinge, which is 14.11, which is pretty close to our 15 mil that we wanted. So next we're going to actually go ahead and create a base flange of this hinge. So I'm going to open a new sketch on the back here and go normal 2. Just create an approximate sketch like so, and we'll dimension that accordingly. Say 15, I believe, and from this edge as well at 35. Now it's here where we can actually apply our global variables that we just added in, right plane. We want that global variable to be equal to the hinge, but divided by 2. Therefore, our hinge on one side of the right plane is half, and the other side is the other half of that hinge. Now we can go into our sheet metal in the command manager and create a base flange from that. And we're just going to reverse that direction and uncheck merge result, creating a multi-bodied sheet metal part. Okay. So next, we're going to just introduce a feature called break corner trim, and we're going to apply a 10mm break of a radius just on the corner here, just to unsharpen it really. Okay, that's a nice little feature you can do with the corners. So next we're going to create our hinge. What I'm going to do is I'm just going to double check that our internal radius is 1.5, which is correct, and that's going to be for all multi-bodies here. Now we can go into the multi-body and edit it if we want. We can overwrite it for that multi-body, but it's right now, so we'll okay that. Normal 2, the face that we want to sketch off. And what we're going to do is we're going to create a edge flange. So edge flange, we're just going to select this edge and extend outwards like so. Now the dimensions that we're going to apply are going to be this internal radius, which is fine. We're going to have a degree of 50, just to angle it like so. We're going to have an end condition of 4mm, and that's going to be from the internal or the inner virtual sharp, which is from this edge here, to the imaginary internal virtual sharp, which is between this edge, or where this edge and this up edge here meets in the middle here. We're going to have that bent outside, so we can accept that, and we can move on and create another edge flange just on this edge here. Extend that out to there, it doesn't really matter. We'll just make that 50mm as well, 50 degrees, and we'll have an end condition of 2 degrees with the same parameters or flange position as before, and accept that. Okay, the next thing we want to do is add a hem. So we did it before, but we're going to apply a rolled hem this time, and we're going to have it at 300 degrees with an internal radius of 5mm. We're going to select the edge of where we want that hem to be, right there, and that'll extend right the way along our edge flange like so. Okay there. Alright, so the next thing we want to do is actually cut this up so we get each individual hinge. So I'm going to open a new sketch on the right plane, and I'm going to select this face and this, and this, and that, and I'm going to convert those entities on the sketch plane. So I can use that sketch now to actually cut away my hinge. So what we can do is we can offset that, because we don't want it starting cutting from the sketch, we want it starting cutting from about here. So we can use our global variables that we've got, and what I want to do is, I'll just get out my equations. We've got our hinge, and we actually want to times that by 1.5. Okay, and we'll just reverse that direction. So it's taking this hinge size and half this, and it's just cutting it here. Now we just need to have a blind condition of the global variable hinge at 14.11, and our selected bodies, our feature scope, we're going to have it on just this body here. And okay that. Alright, so now that has been completed, we can move on and we can actually create a linear pattern of this cut that we've just performed. So we're going to go into our linear pattern here, and we're going to select a direction to cut along. Now it doesn't matter which edge you're selecting as long as it's in the right direction of your linear pattern. So our distance is actually going to be equal to a global variable, which is going to be hinge times 2, because we want to do every second one. And our instance, that's going to be another global variable that we created, and it's going to be our odd. Alright. Now features to pattern, it's going to be that cut automatically selected, and we're just going to have it on just this body here. Okay there. So that cuts away quite nicely like so. And it's just down to us to now mirror that across to the opposing side. So I'm just going to rotate my model, wrong way, like so. Now I'm just going to mirror now about the right plane. Okay, and the body to mirror, we're going to select this body, and we're not going to have merge with solids together. We're going to have another solid multi-bodied feature in our model. Okay, so the next thing we're going to insert into our model is actually a forming tool. Now I've created a forming tool already, but I haven't told it that it is a forming tool as of yet, although it is in our forming tools folder. So to do that, we can go into our command manager under sheet metal, and we can select forming tool and close that now, save. Now we can actually insert that into our model like so. So grab that and we can drag it onto our model face, and we can rotate that 90 degrees. Now if you want, before you rotate or anything like that, you can actually alternate between faces by selecting your tab key, but this looks like it's actually forming in the correct direction. So we can just go into position now and just go normal 2, and we can position our forming tool to the correct location. So I'm just going to grab the midpoint of this, and I'm going to make that horizontal like so. Do the same at the bottom here, select the midpoint and just make that sketch point vertical. Okay, now our sketch is fully defined. We can OK the position and OK the feature like so, creating our indent at the bottom, which is actually giving some strength to the bottom of our sheet metal part. So the next thing we can actually do is mirror another impression. I'm just going to drag an impression on this side here, and we'll just go normal 2, and we're just going to adjust the position of that. So like before, I'm going to select the midpoint and the origin and vertical. Same on this side. We'll make it horizontal. And that's actually perfect now. So all we need to do, OK that off, and we can go ahead and we can actually mirror that about the right plane. So rather than dragging in a new one, we won't do mirror body, we'll just mirror the impression. Okay. So now that is done, we can actually remove our reference dimension here. So we go into our annotations folder and we'll just say uncheck show reference dimensions. We'll just give that a save. And now we want to go ahead and create the lid for this box. So we want to insert that into an assembly. So we'll just make it in context. Okay, we'll OK that. Now we want to center the origin of our model to the center of, or the origin of the assembly. So I'm going to hit the green tick rather than selecting in the graphics area. Now I'm going to give that a save. So file save as, and I'm going to save that into a correct location. We're going to call that ammo box. Save. Okay, so now with that saved, we can actually start creating our in-context lid. So to do that, we'll go into Insert Components, New Part. Now be careful where you select next, because wherever you select will be the front plane of our new model. So I'm going to actually select the front plane of the assembly, which we know is going to be the front plane of this box as well. So we expand our new part that we're creating, and it opens a new sketch on that plane. Now we don't want to create a new sketch just yet, so I'm just going to exit that. But all we need to do is create a reference geometry plane first. Now I'm going to create a tangent to this face here. So on my second reference, I'm going to select as the top plane, but make it parallel to that. And there we have it. We've got our plane selected. So now I'm going to open a sketch on that and just go normal 2, the other side. Okay, So with that selected, sorry, I was on the right side to begin with, we can now create our next base flange to create the lid. So I'm going to select this edge here, and I'm going to show you a good tool to actually trim away some edges. First I need to go and select 3.4 and reverse direction. So I just have to go around. So I'm going to show you we can offset this edge here. I'm going to show you a good tool to trim away some edges as we go along. So just bear with me while I offset these edges. And finally one down the bottom here, like so. Okay, so a good tool we can use to connect these up together as well. We can select our trim entities. Now rather than selecting our extended entities, we can use our trim entities tool, but holding shift key down we can actually drag our entities across each other like so. Release shift, and now we can use our power trim. So nice and quick to create a closed sketch. So shift, drag, and then release shift and trim. Nice and quick. Okay, so now our sketch is fully defined. We can create a base flange from our sheet metal here. So we'll just extend that round, and we'll just rotate or reverse the direction, and we're leaving it at 1.5 thickness like the rest of our model for ease, and we've created our next feature, well, or next part. Okay, so what we want to do is introduce the miter flange. So the miter flange first asks for a face to sketch on, so I'm going to sketch it on this face here and go normal 2. Now I'm going to create a sketch of our miter flange, which is looking something like this. Pretty rough and ready, but it's going to give us approximately what we want it to look like. Now I'm referencing it to our model, but when we lock these out they will lose their reference. We'll come to do that a little bit later on, but for now the sketch is fully defined. We can go ahead and we can go into our sheet metal tab and select miter flange again. Now we want to select the remaining edges, but I'm just going to adjust a couple of things inside our parameters here. So we actually want the internal radius to be not the default, but actually we want it to be 0.1. So it's going to be very, very tight. We want our gap distance, well, on our miter flange to be 0.1. So that's where it meets at the corners. And we need to select the remaining edges right now. So we'll go through, select this edge and this one, and select that edge. Now with that selected, hit my right mouse button to accept the edges we've selected, and it'll automatically create the miter flange like so. Alright, so now I want to actually cut away these corners just to match it so they're rounded corners like this. Now this is not exactly a good looking model, I know, but it's just giving you an example of what we could do. So actually I'm going to convert this edge, or offset it anyway, offset it by 1.5. We'll do the same for this lower end here as well. Could just convert it, but I'm just going to offset it a little bit like that. I'm just going normal 2, and I'm going to close those sketches off like so. Just bear with me while I add in the relationships and finish off this remaining sketch down here. Okay. Now I want to do the same on the other side, so I'm going to create a construction line down the center. Doesn't have to be perfect, but I'm going to select those to be mirrored about this line here. Okay, now that's actually created, we can actually do a feature cut, and I'm going to cut that up to next. Okay there. Alright, so that's giving us a nice cut around each of the corners. Just giving you an example of what you can do with Hinge that we created earlier, but I'll go a little bit slower and we can create a sketch on this face here. So like before, I'm going to just create a square. I'm just going to relationship that to our lid. Okay. And our last relationship, I'll match it to that edge there. Just give it a dimension as well from there to there, same as before, 20. Okay, so now we can actually create a base flange from that. And I don't want that to be going inside our model, nor do I want it to be merged. So I'm going to reverse and accept those defaults. Okay, so now we'll do the same again. We're going to cut the corners of this. So we'll go into our corner and break corner. And it's defaulted to what we put in last, which is nice. So we don't have to re-enter in our same details as before. And accept that. Now we want to insert a miter flange on this actually. So what we can do is we can select miter flange, and we need to select the face to sketch on. So I'm going to select this face because I want the miter flange to be running down this edge here. Okay, so now we need to sketch our miter flange. We'll sketch it from the corner here down to the internal radius of that. Select the sketch line and the internal radius and make them tangent as well. Okay, so now that's done, we can go ahead and we can create our miter flange in our sheet metal like we did before. Now, it's currently sitting a little bit wrong. We want the internal radius to be 1.5, which is default, which is good. We want the flange position to be outside though. So that's actually looking quite good now. We'll accept that. So if we have a look at that, we can see that it extends from one side of our base flange to the other nicely. So it's just remaining now to create the hem, which we created earlier before. Now if I select the hem tool, it should have the same dimensions like it did before with our miter flange. So all we have to do is select the edge in which we want that hem to be on, like so. And okay, so all we have to do now, like we did before, we have to just cut away the edges or hinges of where these hinges are coming up. So we need to cut that section away, and the same on the other side. So again, like before, I'm going to open a sketch on the right plane, and I'm going to select this edge, that edge, not that one, that face, sorry, and convert those entities. Now, before we move on, I need to select the other feature that was used to create lower hinges, so I can use those dimensions in our new cut here. So what I'm going to do is I'm going to double click on this face, which will bring up those dimensions that we used to create those previous cuts in this lower hinge. So now I can go into my features and I can go into my cut, and I can offset that by a certain distance, which is going to be this distance times by 0.5. We want it in the other direction there. So what that's doing, it's cutting away, as you can see, it's cutting away this lower hinge from the top hinge that we're creating. Now we need a distance, so again I'm going to just use this distance, so keeping it nice and even, and we just want the selected bodies just to be this body here. Okay there. Alright, so that's cut away nicely, our top hinge away from our lower, like so. So what I'm going to do next is I want to linear pattern it across like we did before. However, I want the global variable to be inside this lid. So I'm going to expand my part here, and I'm going to right click on the equations and manage the equations. Now I'm going to create a new one, and it's going to be called instances. Now we can call it instances odd because it is going to be odd. And what it's going to be, it's going to be the linear pattern from the previous example. So if I can just double click on this face here, it should bring up, there we are, the 9 from the previous example. Okay, so with that done now, we can go into our next linear pattern. So what we need to do is, again, we need to double click our previous dimensions just to bring them up. We can go into our linear pattern now. That's fine, we'll just OK that. Need to remove that warning. Now we want to select an edge to be across. We just want to reverse that direction. So it's looking pretty good so far. Now we need to select the distances from the middle of one of the hinges to the middle of the other hinge. So that's going to be equals to the distance here times by 2. So it's going to be doing every second one. Now our instances, that's going to be equal to our global variable that we just created. And our features to pattern are going to be from our feature tree, and it's going to be this cut that we just created. Yes, I know. Just clear that out again. We'll just reselect it. There we go. Now we're going to select the body we want it cut to, which is going to be this one. Okay. And we'll OK that. There we have it. It's cutting away this top hinge away from our lower hinges here. So all we need to do now is we just need to mirror it across to the other side. So that's simple enough. We'll go into our mirror and we're going to mirror about the right plane of this component that we're editing. So right plane here. And the features we're going to mirror is going to be our linear pattern. Okay, so we'll just accept that. And there we have it. We've got our hinge, which is nicely to the top of our lid. So all we need to do if we want to test this to make sure it moves up and down, we need to cut the link now. So we just come out of Edit Component and we'll right click and we'll list the external references like here, and we'll just lock all. Okay. Okay, so now we can go ahead and we can expand the mates folder. And we'll just suppress this mate now, which is keeping it in place at this stage. So what we want to do is we want to add a couple more mates so we can actually open this lid. So I'm going to add a concentric mate here. And I'm going to select the right plane of the lid and the right plane of the assembly, and I'm going to mate those together coincidentally. Okay, that. Right, so now we should be able to lift this lid nicely like so. Okay. Now if we want, we're going to save that externally. So we're going to save that part. We'll just rename that to say lid. And we'll save it in the same location as our box. Okay, we'll just save that. So we've saved the assembly as well. Just save it as well. Save all. Rebuild. That's fine. Now if we want, we can actually insert another impression on the top of the lid here, just to strengthen that. So I'll right click on it and open this part up. Now because it's all associative within SolidWorks, whatever I do in here will reflect back to our model, our assembly model. So I'm going to grab this strengthen, drag it and place it on the underside of this. And I'm going to rotate that 90 degrees. So just like before, we'll go into the position, we'll just go normal 2. There we go. Select the midpoint of that and then the insertion point, and we'll make those vertical. And we'll do the same for this. Just select that midpoint and we'll make those horizontal. Now our sketch is fully defined. We know it's in the center. We can OK that and OK our position, giving us our insertion on the top, giving it strength to our sheet metal part. We'll save that away. We'll rebuild that. That's fine. And close that off. And we'll update our assembly, giving our insertion at the top here. So that's quite nice. We've got insertion top and bottom. Now I want to show you an example of the box adjusting in size. So what we're going to do is we're going to actually, in place, we're going to suppress that, unsuppress, sorry, and we're going to right click and we're going to list the external references again. And we're going to unlock them so that they will update together when we adjust the box size. So we'll go in and we'll just double click on the base and we can see the difference, say double the size. And we'll do a Control Q twice just to update. So it's adjusting the lid, the box, and all those hinges and all those equations that we added in. And I'll do another Control Q just to be sure. Alright, so if we rotate around, we can see the hinge has been updated nicely, giving us our perfect hinge at the back. Alright, so that brings us to the end of our webinar.